Hello everyone and welcome back to the channel. Today we are going to design and simulate an electric vehicle charging system using the constant voltage method in MATLAB or Simulink environment. So what is constant voltage charging? It is a method where the charger maintains a fixed voltage across the battery terminals, and as the battery charges, the current automatically decreases. This technique is widely used in the final stage of EV charging because it prevents overcharging, ensures safety, and helps extend the battery's lifespan. In our simulation, we will be using a 96 volt DC input to charge a 24 volt 20 ampere hour lithium ion battery that starts at 50% state of charge. We will set our voltage reference to 26 volt and uses a PID controller with P equal to 10 and I equal to 200 to keep the voltage steady. If you are passionate about electric vehicle, battery management or MATLAB simulations, make sure to watch till the end and don't forget to like, share and subscribe for more exciting engineering projects. Let's get started. You can see the specifications of lithium ion battery, controller as well as the input voltage, resistance, inductance, switching frequency as well as the sampling rate. So here we consider the runtime is 10 seconds. Let's start with the power GUI block. So search it, power GUI. So this simulation is similar to the constant current method. So in the constant current method, what happened? We make the current constant, but here we make the voltage constant. Okay. So here you can see I already taken the power GUI. Then I have to take DC voltage. The simulation is almost similar. DC voltage. Then here I am taking the MOSFET switch. So I just search it out. So here you can see this is the MOSFET switch. Then I am taking battery. So here you can see battery. Okay. So here you can see I am taking the power GUI as a discrete. So it is discrete and its sampling time is 20 milliseconds. Okay. Now this is the DC voltage source. Here I am taking the 96 DC voltage and now connected the MOSFET. So I am connecting the positive to drain, source to drain. Okay. Source to drain, and this negative portion is connected to the source. Okay. Now I have to connect the R and L branch. For that I am using series RLC branch. So here I am selecting R and L. So here we consider the resistance as 0.05 ohm and the inductance is 10 millihenry. So 10 e to the power minus 3. Now just apply it. Now I am connecting this and it is connected to the battery. So now I am just changing the battery terminal and flipping the battery terminal so that we can easily connect it to the other components. Okay, you already know how to flip that up down. Okay, so now connected to the positive terminal and here it is connected to the negative terminal. Now we have to find the signals that are coming from the battery, so that's why we are using the bus selector. Okay, so this is the bus selector. Now I am connecting this one. Here you can see. So just double click it and remove these two signals. Here you can see, and just add this SOC, current and this is the voltage. Now here I am using the go to signal, go to and from block. You can also directly connect it to the scope, but for the better presentation as well as the visualization, I am using the go to block. Okay, so here what happened, we have to take the 3 go to block as the 3 signals are there. One is the SOC and second one is the current and third one is the voltage. Okay, so I think I see. Okay, now it is okay, just connecting it. Now I need scope. So here you can see this is the scope. So we need 3 inputs. So go there, setting 3 input, and I am changing the layout, just 3, just apply it and okay. So here you can see, just here you have to use the from block, just go to the back side. Here you can see, you just drag it and you get the from. Similarly for the current as well as the voltage. Okay, now this part is completed. Now coming to the controller part. Okay, so here I am using the PI controller. So I am searching that PID controller, just adding it. So here you can see PID controller is adding. To compare the 2 voltages, we required sum block. Just sum, just wait. So here you can see sum block is there. Okay, so I have to compare. So that's one is the positive and second one is the negative. Okay, here I am taking the constant block because the reference voltage is, I am taking the 26 volt. This is the constant block. I am taking as 26. Okay, I am connecting it. Now for the compare, here I am taking the voltage profile. Just rotate it and connected it. Now we have to generate the signals. So that's why we require the PWM generator, because we need the pulse to control the switching. Okay, so that's why we are using the PWM signal. So here you can see I am taking PWM generator DC to DC. So here you can see D means it is the duty cycle, P meaning pulse. This pulse is directly go to these 2 switches. So here I am consider this switch is switch 1 and this is the switch 2. Okay, now I have to change the controller name, that is the PI. So here I am changing, this is the PI and the P value is 10 and integral value is 200. Okay, now double click on the DC PWM generator. Here I am consider the switching frequency as a 10 kilohertz and the sampling is 20 milliseconds, sorry, microseconds. So 20 e to the power minus 6. Okay, now we need go to block. So here I am taking, and this is for the switch on. And for the switch 2 operation, here I am using logical operator. So just search it that is the logical operator. So here you can search it, otherwise you can also search as a AND gate. So just add it. So I got the AND gate, and now double click it. You can see lot of logical operators are there, and or, but here we need only the NOR operator. Just apply it, okay, and connect it, and this pulse is for the switch 2. Okay, now just connect the signals. So this is directly go to switch 1, and this is directly go to for the switch 2. The battery parameters. So here you can see this is the lithium-ion battery. Okay, then we have to choose its nominal voltage is 24 volt, its rated capacity is how much, 20 ampere hour, and we consider the initial charge is 15. Just apply it and okay, and then run the program. So here you can see for the constant voltage we are using the voltage as a reference. Similarly, in the constant current method, that time we are using the current as a reference. Only these difference is there, otherwise everything will be the same. Okay, so here you can see the battery is charged from 48.3% SOC, and it is continuously increased. Similarly, here you can see the voltage is constant at 26 volt, and to maintain the voltage as constant, what happened, the current is continuously decreasing. Now I just change the voltage reference as a 30 volt and try to run this program and see what happened. I think similar case will happen. To make the voltage constant, what happened, current will be the decreased. This simulation is very easy. You can take as a reference of this simulation. Okay, here you can see the SOC percentage is continuously increasing, means the battery is charged, where the voltage is, here you can see it is constant at 30 volt, whereas the current is decreasing. Okay, so here we saw how maintaining a fixed charging voltage while allowing the current to decrease ensures battery safety, prevents overcharging, and extends battery life. If you enjoyed this project or learned something new, please hit the like button, subscribe to the channel, and click the bell icon so you never miss future MATLAB and EV technology videos. Drop your questions or project idea in the comments. I would be happy to explore them in upcoming videos. Thanks for watching, and see you in next time.